of 13,000 milliwatt hours. Okay, or anyways, 13 watt hours, okay? 13, what's a third of 13? A little bit more than 4, okay? What's 13 plus 4? 13 plus 4 is 17. It's actually 19 watt hours. But I'm giving, I don't want to call it 40% more for a number of reasons. Mainly, I think that there are some 3600 milliamp hour batteries or 18650, and I think those would be considered about 15 watt hours. So then the 19.5 watt hour 21700s are, again, they're only in about 30% more energy. But point is, you're getting 30 or 40% more energy for something that's only 15 or 20% bigger. Okay, so keep that in mind. 21700s don't just have more energy than 18650s because they're bigger. They have more energy density. They have more energy for their size. And on top of that, they put out more amps. Now, that's not always on top of each other. Okay? In other words, the 3000 milliamp hour 18650 Sony VTC6 puts out 30 amps. The 21700 that I have in my L30 AceBeam puts out 20 amps, and it cannot put out 30 amps. Okay, you need a 4000 milliamp hour or so 21700 to put out 30 amps. So that being said, most 18650 flashlights plan on about 20 amps at very most, and for that reason, they tend to plan on running on a weaker 18650 because there's only one in the world that can put out 30 amps. And because of that, they're not really getting the same lumen output that they technically could with the very best. So that the Sony VTC6 is sort of irrelevant, but if we pretend it is, 21700 is still better because it's actually 25% more energy, and it narrows the gap a little bit because it's only 25% more energy, but it's still putting out the same amperage. Okay, so, and it's still 5%. It's at the end of the day, it's still 5% bigger. 5% end of the day more energy. Okay, so when you factor in size, it still has 5% better performance. Okay. I think they're getting some 4200 milliamp hour cells soon that use the same chemistry. The Sony VTC6 is a modified lithium ion. There are different lithium ion chemistries, and they're all different from lithium polymers. One truth of CR123s that are lithium is that they're better in super low temperatures. But there are newer 18650s and even 21700s that are designed to work in cold temperatures. Even so, CR123s can still run at even colder temperatures. Okay, and so there's uses for them because of that, and also because they don't have to be recharged, and so they get thrown away once you use them. Okay, usually you have an exhaust pouch where you put your exhausted batteries, but technically speaking, if you really needed to, although they're very light. Another interesting advantage, CR123s have the same energy density in weight, but not in size, as 18650 and other batteries in weight. Okay, this is because lithium are very light metals. What's used for them? I forget if that's the anode or the cathode, but the anode or the cathode that isn't lithium, it's also very light. Okay, so lithium batteries, right? Well, there's also what are called Energizer, and I'm not ripping Energizer. I'm telling you, Duracell and everybody else does not make them. They just simply, there is no other company that makes lithium batteries other than Energizer for AA's and AAA's. Okay, they don't make D's or C's. They just make AA's and AAA's. Okay, In both cases, they're high amp cells. I think they put out like 2.5 or 3 amps, which is crazy for a AAA and a AA. In any case, all right, CR123s. Okay, they're very lightweight. So for the military, if you want a lightweight flashlight, you're going to use CR123s. And the other thing is, when you've exhausted your cells, you're going to put them in an exhaust pocket and carry them around with you. But they're really light, so it doesn't matter. If you exhaust 18650s, not only would you want to hold on to them because it would be expensive to throw those out and dangerous, but because they'd still be flammable. 18650s, when exhausted, are going to be heavier than CR123s. Okay, and I might even go so far as to say that I think the CR123s might actually be better in weight density than 18650s by a small margin. And you got to remember, once you've used them once, they're trash. So, it's a small margin, but they might actually have better gram to watt hour performance than most lithium ions, but it's narrow. It's a narrow advantage. Okay, the other thing is they should really be compared to 16340s because those are going to have the same material size. And I've felt the two in my hand, and you can definitely tell the difference. The 16340s are definitely usually going to be heavier, but they have a little bit more energy. So I don't know. I'd have to do some sort of math for that. I don't care because flashlights, most of their weight is in the flashlight itself, not the batteries. But I actually do care when I use alkaline AA's because I prefer to use the Energizer lithiums, especially for headlamps. They're a little bit lighter, and when lightness matters, I would say lithiums, especially AA's, will have a little bit of an advantage over lithium-ion 14500s, which are AA 3.7 volt cells. So they have their advantages. Okay, but they're very narrow advantages. Okay, most of the time you're never going to have a flashlight that cold, all right, because it's going to be in your hand or in your pocket until you use it. And once you start using it, it's going to keep itself somewhat warm, especially at higher outputs. I see the lower outputs, camping, CR123s start to make a lick of sense, just some sense. Okay, it's still illegal to throw them out in the forest. You still want to hold on to them and carry them out, but they are lighter once you've used them once. And anyways, so unless they're doing like long distance, like through hiking, which I've done before, and I took CR123s as a backup, but I had plenty of power without ever touching them. So I used them just for fun for a little bit, but yeah, I had plenty of other 18650s that were already backups. I'd do stuff without it. But if you're in the military or if you're on a boat that is a sailboat that doesn't have any gas, where you have any kind of generation of electricity, then I guess, then you might use one. It's still a solar panel when you're out on a boat, especially if you're sailing in the normal summer seas. You're going to get plenty of light to charge your lights. Plus, if you're really out on a sailboat, you don't really need that much light because you're not going very far, not doing anything. You only need it for like a few hours when you get close to shore, and that's about it. In any case, as long as your navigation's good. Like, you don't want to crash into land, but again, if you crash into land, you can just hop out of the boat and get onto the land. Hopefully you don't hit rocks. But getting back on topic, I mean, it's just, you don't really need CR123s. They're ultimately outdated. Okay, unless you're like shooting with guns where the lighter weight and everything actually helps, there's really no reason to use them. Okay. Also, 18650s are outdated. So we really need to be using 21700s, not because they're bigger, but because they have more energy density by about 15% in most cases. Okay, so and there are 4,000 milliamp hour cells, and I think smaller ones that actually produce something like 50 amps. I think they're 3,800 milliamp hours, and they produce 50 amps reliably, like current straight a long time. At 50 amps, that's a lot of power, folks. That is like 50 times 4.2 is like over 100, you know. I mean, 50 times 4 is 200